big topic that's going to take up most of our time today is, where did they put my stool? No, that's not the big topic. Ah, there we go. That's a little topic. The big topic is how tables work. So what a table is an association between keys and values. And you've seen different kinds of tables by now. You've seen a two-dimensional table back when we did data-directed programming. The code on the screen here is for the simplest possible version where there's only one table and it's one-dimensional, because I like to start simple and work up. So the first thing is to talk about association lists, which are up on the top board there. An association list is a list whose elements are key-value pairs. A key-value pair is a pair whose car is a key and whose cdr is a value. So that's a pretty simple definition. It's a very useful idea to have in many, many situations. So much so that Scheme comes with procedures that know how to deal with association. Well, one procedure anyway that knows about association lists, and that's assoc key in association list, which returns a key value pair, or false. So if the thing you're looking for is in the association list, it doesn't return the value the way our table structure does. It returns a key value pair. And we'll see in just a moment that that's useful for allowing modifications to the table. It's also useful if you need to be able to distinguish a key that's associated with the value false from a key that isn't in the table at all. Because assoc, if it does find a match in the table, always returns a pair. So in one case, you get back a pair whose cdr is false. That's if the value in the table is false. Or you get just plain false, meaning that the key was not found in the association list. So let's go ahead and make an association list. Define a list to be the list. I don't know. John rhythm, Paul bass. Well, no, I should make it John dot rhythm, Paul dot bass, George dot lead, and Ringo dot drums. Okay? So here's my association list, and now I can say assoc Paul, quote Paul, a list, and I get back not the word bass, but the key value pair, whose car is the key I was looking for and whose cdr is anything. So if I say assoc Mick a list, I get back nothing because he's in the wrong group. Okay? Questions about association lists? Good. This association lists are a really, really, really ancient Lisp data structure. There have been A-lists since the very beginning in 1962 of Lisp. And they've survived, again, because they're really useful. Now, for making a table, the obvious thing to do is just use an association list as the table. That's not what we do. Instead, we have this yellow pair, which is a header. It's, it sort of serves two purposes. You can view it as attaching a type tag. Right? So this is a thing of type table to the association list. But it's more important than that. It serves as what we call a sentinel, or sometimes dummy node. Those are names for this pair. Because the reason for sentinel is you put them at the front and maybe at the end of a list or an array. It's a very common technique, even in those other ways of doing things, to serve as endpoints, pseudo-elements of the structure. And this often saves you writing special case checks for running off the end. So sometimes, for example, you'll see algorithms for searching sorted elements in an array. And what they do is they put the value minus infinity at the front, and they put the value infinity at the end. And so you're always guaranteed that anything you're looking for is within the limits of this array, even though those aren't really part of your data. And we're going to do sort of the same thing. We're using this as a sentinel, not because its value is less than anything else. That's a different use. Here, it's for two things. One is it makes an empty table not be a special case. So when we're talking about looking things up in the table or inserting things into the table, you'll see in a moment that we don't have to have any null question mark checks to handle an empty table differently from any other kind of table. And the other thing that's important about it is it allows us to maintain the EQ-ness of a table even if all its elements are gone or it doesn't have any elements in the table. So imagine, if you will, that there are 4 different variables that are local to different procedures in your program that all happen to point to the same table. And let's say now that we want to cons a new pair at the front of the association list, because that's how you add an element. Well, we did that for one of the variables, and we could say set bang this variable to cons new element, the old value of the variable. But those other variables that pointed to the same table don't anymore, because the frontmost pair of the association list isn't what it used to be. Having this sentinel node avoids that problem, because any variable that points to the table points to this pair, and each table that we make will have a different one, and it's always going to stay the same. So you can rely on any set of variables that point to it continuing to point to it no matter what happens in the program. This, I guess, might sound a little abstract until we actually look at the code,